Hello everyone. This is in continuation with today's live session. We completed other tabs except for the last two tabs, mixed stream and amortization tab. In the mixed stream tab, we are trying to calculate the future value of different cash flows. So there are two different ways. One way you can directly get the future value. Other way you first get the present value of all those cash flows and then get its future value. So for getting the present value, there are two different ways that we discussed in the class today. If you could not make it to the class, please watch the video. And the other way is to get the future value, which we were messing up with. Future value. So if we directly have to get the future value, to do so, I would first like to draw a timeline and show you how should it work. So let's see that in the timeline. This is the timeline with us. I'm sorry, it's not straight. So this is time t0, 1, 2, 3, 4, 5, and 6. Okay, so these are the 6 years over which we are getting the cash flows. So $11,500 of cash flow is at time t1, $12,000 of cash flow is at time t2, and at time t6 it is $18,000 of cash flow. There are some different cash flows in the middle. So one way is to get the future value of all these cash flows. So if this cash flow is generated here, so for how many periods will it stay invested? So 1, 2, 3, 4, and 5. Okay, so if we will get the future value of this first cash flow, it should be for 5 time periods, right? So to do so, and for this one, it would be 1, 2, 3, and 4. So basically, how is it working is the total time, which is 6 years, up to 6 years it has to stay invested, minus 1. So it will stay invested for 5 years. 6 minus 2, because it is getting invested here. So these 2 years will be gone. For third one, when it will get invested here, these previous 3 years are gone. So it's not invested for these 3 years. So how it should work is, because we want to get the future value, so future value should be present value times 1 plus r to the power t. This is our formula for future value. So if you want to calculate the future value at time for this cash flow, which is at time t1, that would be the present value at time t1 times 1 plus r. Now, it won't be like we are not getting the future value of cash flow for 1 year. What we are doing is we are getting the future value of this cash flow, which will stay invested up to 6 years. So it will be there, it will stay invested for 6 minus this time period, that is 5 years. So here it would be 6 minus 1. For the second year, it will be future value of time 2 equals present value at time 2, which is this $12,000, and then 1 plus r to the power of 6 minus 2. So this is how we will calculate it. So now let me show you how will we do it in Excel. So let's get the future value equals present value times 1 plus rate of interest, right, which is this number right here, and we want the rate of interest to stay constant. So so put a dollar sign here, and C. Sorry. It is, yeah, it is C6. Okay. So put a dollar sign here, and for you, you don't have to put the dollar sign. You will just press F4. Okay. Now, to the power of. Now, for power, we will have the time. Okay. So let's see what that should be. It should be D6. Okay. And it should be constant, because every time we will subtract d6 minus d1, d6 minus d12, which is 6 years, minus d7, which is 1. For the next one it would be d12 minus this. For third year it would be this. So this part will remain constant throughout. That's why let's make it constant by pressing F4 or putting a dollar sign in front of row and column. Okay, minus. Now we want this. So this will keep on changing. As we will scroll down, it will keep on changing. So we want put a dollar sign. We want make it a constant here. Okay. So this give us the future value of the first cash flow. Same way, if we drag it, it will give us the future value of all the remaining cash flows. Get it sum of all these future values of every individual cash flow, and it will give us the overall future value, which is exactly the same as we got using the present value formula. Okay, so this is about future value. Now let's talk about the last tab, which is amortization tab. For the amortization tab, always this, what does this problem say basically? It is exactly the same problem that we did earlier when we were talking about ordinary and ordinary annuity and annuity due. It was this problem. Suppose you get a 30-year mortgage loan of $75,000 at the rate of 12% per annum. What would your monthly payment be to repay the loan fully by the end of 30 years? Assuming that the first installment is due at the end of the first month. Okay, so this is the problem. We are solving the same problem. It is exactly the same problem. And in this problem, amortization here, we are trying to see what our interest every month is, how much principal amount have we paid every month. So we have a complete schedule in front of us, and we want to make sure by the end of 360 months it is 0. Okay, there would be monthly payments. So every payment would be, we already calculated the payment here, which is 771.46. This would be every individual payment. So let's start with month 1. These are the months here. So from month 1, it would go until month 360. Oops, I'm sorry. Since I just dragged it by putting just one value, it will copy 1 everywhere, but we do not want that to happen. We want to tell Excel that, okay, we want this series. So you can put 2 or 3 numbers, and then now this series, now Excel will give us the series completely. So we will go up to when this number right here, it turns to 360, will stop there. Okay, all right, let's go there. Let's just do it. Okay, now this is up to 360. So we have 360 months. Now we want this complete schedule for 360 months. So what was the beginning balance? In the beginning, we had the balance of this. Okay, this was the beginning balance. How much total payment is? This is equal to this payment amount. Now I am using this amount as like the positive number. I will not use, while preparing the schedule, I will not use any negative numbers that way, because I want to show, I will take care of that part by showing addition or subtraction, those kind of things. So I don't have to show it as like I made a total payment of 771.46 Okay, so this is the payment. Now in this payment, what is the amount of interest which is included? So basically, how would you calculate the interest? Your beginning balance, right, times your interest rate. Like it will be like for 1 month, so times your interest rate, and we will have to make it constant. The reason is every time beginning balance will change, but our interest rate will remain the same. Since we want to keep it constant, so press F4 at this stage, or like put that $sign. Okay, so this is our interest amount. Now what is the principal? This principal here means the amount of principal that has been repaid. Okay, so that was the total of this much minus this was the total payment, 771.46. Out of this total payment, we paid $750 as the interest amount. So how much principal did we pay? That was $21.46. So now what is your ending loan balance? Okay, you cannot say that loan balance would be beginning balance minus total payment. No, because we did not pay the full principal, right? This total amount doesn't, it includes $750 as the interest for that month only. So we paid that month's interest, and $21 as principal is repaid. So to get the ending balance, we will subtract this principal amount from the beginning balance. This minus whatever principal has been repaid. So this is how we will get the ending balance. So for the first month, after the first month, if you will look at the situation, it was the beginning balance in the first month. Then during that month, we made a total payment of 771.46. In this total payment includes $750 as interest, remaining 21.46 as the principal, and out of the beginning balance, we will subtract the principal that has been repaid, and that will give us the ending balance. Okay. So now this beginning balance should be exactly what the previous month's ending balance was, right? Now this payment will remain same. This payment will not change. Here I did this C10. I should make it constant because our payment is not going to change throughout. It will remain the same. So if I make it constant, this payment will exactly be the same, right? Sorry. This payment is same. For interest, it will copy the formula, and the formula was beginning balance times our interest rate, and interest rate, you remember, we made it constant. And for principal, what formula did we use? E10 minus F10. That means total payment minus the interest. So again, it is taking care of that part. For ending balance, this is how it is working. So what we can do here is, now we can fill the whole thing up to the very end. What did it do? I'm sorry, let me see. I don't know what did it do. Although it shouldn't have worked that way. Okay, yeah, now it will work. So it didn't work for the whole thing. Now you will be worried like what these zeros are, but they will change automatically. Don't worry about that part. Everything will change gradually. Okay, so just double click here. So look, everything changed once we changed it, because that is cross-referencing which has been used. And now we can see that at the very end it is like really close to zero. It is just because of like some approximations. That's how it is working, because of that approximation thing. Otherwise it will come out to be zero at the very end, that the total payment that we have made. So that's how this amortization problem works. Like you can check your schedule whenever you want to, like if you have that complete schedule ready with you, like after these many months. For example, if you want to repay your loan fully after, let's say 200 months, then you can see, okay, this is after 200 months, this is our ending balance. So we will pay this ending balance and we will get rid of our complete loan amount. Okay, so that's how this amortization problem works. This is all about it. And yeah, that's all about it. Thank you and have a great time ahead. Feel free to ask any questions. Feel free to email me whenever you feel you have any questions or concerns related to it. Okay.